Hi, welcome back to Math 111. We're going to continue on with our study of polynomials and specifically the zeros of polynomials. And in this video, we're going to talk about a technique that will allow us to generate the list of all possible rational zeros of a polynomial. Now remember what rational numbers are. Rational numbers are numbers that can be expressed as a fraction. And I've got here on the screen the rational zeros theorem. And what this says is if we've got a polynomial of the form a sub n times x to the n plus a, so in other words, we've got an nth degree polynomial with a leading coefficient a sub n and a constant coefficient a sub 0. And these two numbers, actually all of our coefficients are integers, so no fractions. Then r, the number r, is a rational zero of this function if it's one of a certain set of numbers. And that certain set of numbers come from the factors of this leading coefficient and this constant coefficient. So we're going to call p's factors of the constant term and q's factors of the leading coefficient. And then we're going to build a list of p's over q's. And the bottom line is that any rational number that is a zero of this function will come from that list. So that's a lot of math speak. Let's put it to work. So we're going to consider the function f of x equals 2x to the fourth plus 4x to the third minus x squared minus 6x minus 3. And we are going to list all possible rational zeros of this function. Okay, so my constant coefficient, or my constant term, is a sub 0, and that equals negative 3. My leading coefficient is my a sub n, which is 2. So I need to generate these p's and these q's. So my set of p's are factors of the constant coefficient, the positive and negative factors, so 1 and 3. My q's are factors of the leading coefficient, positive and negative, so positive and negative 1 and 2. So my p over q's, that's every p divided by every q. So positive and negative 1, positive and negative 1/2, positive and negative 3 over 1, or just 3, and positive and negative 3 over 2. These are all the possible rational zeros of this function. Let's try another one. That one was relatively simple because those leading coefficient, or those coefficients, both the leading coefficient and the constant term, were prime numbers. So my list of factors was pretty straightforward. Let's try this again. Let's list all possible rational zeros Notice I'm not finding the zeros, I'm just listing them, listing the possibilities. For the function x to the fourth plus x squared minus 12. Now you may remember that this is what we call quadratic in form, and for finding zeros we could actually factor this guy. But I don't want to do that right now. I want to find all possible rational zeros. And then we'll actually go ahead and figure out which ones of those are zeros and their multiplicities. So my p, well, let's start with this way. My constant coefficient is negative 12. My leading coefficient is 1, because there's an implied 1 in front of that x to the fourth. So my set of p's are all the factors of 12, which means 1 and 12 and 2 and 6 and 3 and 4, and they're all positive and negative. Now my leading coefficient is just 1, so my q's are just 1. My possible rational coefficients are 1 over 1, 12 over 1, 2 over 1, 6 over 1, 3 over 1, and 4 over 1. I hope this has been helpful. In the next video, we will take this, we'll put these all together and we'll find zeros, real zeros. We're not going to find imaginary ones yet. We'll find real zeros. And talk some more. I'll see you soon.